Hello, welcome to the presentation of 3D printing in healthcare systems. What is 3D printing? 3D printing is a type of additive manufacturing process which is nothing but instead of starting with a solid block of material and cutting it down to the required shape, an object is built by adding one layer of material at one time by a printer, and that too with the help of a computer. 3D printing is in healthcare is an evolutionary market which will reach its potential in the next 4 to 5 years according to Gartner. 3D printing technology involves implants, surgeries, prosthetic operations, and in future it might serve as an alternative for the organ transplant too. There are several benefits of 3D printing technology, and some of them are: the objects are created without the use of molds or dies. Next, it allows product to be created on demand. That means anytime object is needed, you can print it. And thirdly, it keeps the cost low because the design changes can be made quickly and easily with little or no additional cost. So next we'll see how the printing is done. 3D printing starts as a digital 3D design file like a blueprint for a physical object. This design file is sliced into thin layers which is then sent to the 3D printer for the printing. From here on, the printing process varies by technology, starting from desktop printers that melt a plastic material and lay it down onto a print platform to large industrial machines that use a laser to selectively melt metal powder at high temperature. The printing can take hours to complete depending upon the size, and the materials used also vary by the printer type, ranging from plastic to rubber, sandstone, metals, and alloys. Some of the major uses of 3D printing in current healthcare are the production of highly customized, affordable prosthetics. Across surgical specialties, 3D printing is enabling a transformation of surgical process. By using 3D models to familiarize themselves with complex structural abnormalities, the doctors are able to optimize surgical planning by rehearsing complex procedures. According to some studies, 3D models have been sterilized and brought into the operating rooms in order to provide surgeons a better view of difficult to see area during surgery. It is being used in printing dental implants and orthodontic prostheses. Similarly, a majority of hearing aids today produced are 3D printed. Every 30 seconds, a patient dies from disease that could be treated with tissue replacement or regeneration. Our human body does have a power to regenerate, but for small distances only. And here the 3D printing can come to the rescue of human beings. Patented in 2003, 3D printing has made headlines for printing of tissues and organs. This process involves dispensing cells onto a biocompatible scaffold using a layer-by-layer approach to generate tissue-like three-dimensional structures. For the bioprinting technology to be successful, it is critical that cells are not affected by the printing process. Extensive research in this field has shown us that the bioprinting organs and tissues are difficult because several different types of cells as well as vascular networks are difficult to fabricate. However, new microfibrillation techniques such as laser-assisted bioprinting are gaining strength. In 2013, first fully cellular 3D bioprinted liver was created using this technique. Similarly, pharmaceutical companies are interested in 3D printing too. There is an idea to create an online pharmacy where patients can purchase a downloadable file according to the prescriptions and with the chemical infused filaments. Below is the Gartner Hype Cycle for 3D printing 2015. As we can clearly see, 3D printing of hearing devices, 3D printing for prototyping has already reached the plateau. It indicates that the most of the hearing aids today in the market are 3D printed, owing to the low cost of production. 3D scanners, 3D printing services bureaus, and 3D printing creation software, enterprise 3D printing have already reached the plateau and can be helpful in the bioprinting of organs and tissues. 3D printing of dental implants showing the tendency to reach plateau. So, In just 2 or 3 years, we can have all the dental implants 3D printed. Coming to the peak of Hype Cycle, we can see the 3D printing of medical devices has reached the peak. But major technology in the medical field to look forward in 3D bioprinting is 3D bioprinting of organs and tissues. Owing to the need of patients waiting for the organ transplant, this is the area we have to see how it traverses the Hype Cycle. As discussed, printing human organs and tissues is not an easy task to accomplish. So we can say that it may take nearly further 5 to 10 years to reach its maturity.